Hello students, welcome to the channel. One of the common questions from Heart of Algebra on SAT Math is interpreting linear equations and linear graphs. That is the subject of today's video. So let's begin. What do we mean by interpreting a linear equation? We know that the standard form of the linear equation is given by y is equal to mx plus c, where m is the slope of the equation and c is the y-intercept. So if I were to draw this on the coordinate plane, and this was my equation y is equal to mx plus c, then this distance is c, since c is the y-intercept, and m is the slope of this line. And the definition of slope, as we know, is delta y over delta x, which means change in y for a unit change, which means a change of 1 in x, right? That's how we define the slope of a line. So if you have presented a linear equation for a situation, then how do you interpret these values? So a company purchased a machine in 2000. The value of the machine depreciates by the same amount each year. So if it depreciates by the same amount, I know it's going to be a linear equation. And the equation for the value of the machine in dollars, t years after 2000, is given by V is equal to 120,000 minus 9,000 t. What is the best interpretation of the constants in this equation? So if I were to quickly try and draw this, then I know that my y-intercept is 120,000. So this point is 120,000. And I have a line that goes like this with a slope of negative 9,000, right? Here I have the value of the machine, and here I have time, where 0 indicates when t is 0, it indicates that year 2000 is represented. So you can see that the y-intercept is the value of the machine in 2000, because that's when t is 0. So here, the best interpretation of 120,000 is the value of the machine in year 2000. That's the value of the machine in year 2000, because that's when t is 0. And what is the interpretation of this 9,000? So let's say I start with 1,000. I go next year, then what will be my value? It would be 120,000 minus 9,000, right? So that's 9,000. So that's 111,000. So in year 1, my value would be, I can write this point as 1,111,000, right? What will be the value in year 2? Year 2, my value will be 2,111 minus 9, which would be 102,000. So I can see that this 9,000 represents the decrease in the value of the machine every year, right? I told you that m is delta y over delta x, change in y for a unit change in x. And x here is years. So 9,000 here is the decrease in machine's value every year. This every year represents the unit change in the x value that we spoke about. So this is how you interpret a linear equation from the constants. Let's look at a question. Sample question. C is 75H plus 125. The equation above gives the amount C in dollars and electrician charges for a job that takes H hours. Now, if you were to interpret this, if I have 75H plus 125, I know that C is the cost that the electrician will charge when he works for H hours. So then what is this 125? This 125 is a constant amount that he would charge just for visiting. Right? That's like if you call the electrician and just for visiting, that's his basic fee. Basic fee for visiting. That's going to be $125. And this 75 will be his hourly fee. Because if he works for 1 hour, then he earns 75 for that hour. If he works for 2 hours, he earns 150. So this 75 happens to be his hourly fee. So the whole point of interpreting it on the graph is the same. If this is the cost of the electrician and this is the time in hours that he works, then when he doesn't work at all and he just visits you, you pay him 125. So the y-intercept is 125 and the slope here is 75. For 1 hour, you pay him 75, for 2, 150 and so on. Ms. Sanchez and Mr. Rowland each hired this electrician. The electrician worked 2 hours longer on Ms. Sanchez's job than on Mr. Rowland's job. How much more did the electrician charge Ms. Sanchez than Mr. Rowland? So the longer way to do this is you first calculate the cost for Ms. Sanchez and the cost for Mr. Rowland. And let's say he worked for X hours at Rowland. So it would be 75X plus 125. And he then worked for, if he worked for X hours at Rowland, he worked for X plus 2 hours at Ms. Sanchez's place. So 75 into X plus 2 plus 125. And then you get the difference of these two and you get the answer as 150. Right? But you don't have to do all that. You can simply see that since the initial cost is the same for both, the difference in the cost between Ms. Sanchez and Mr. Rowland will only be affected by the hourly rate, right? And since he works 2 extra hours at Mrs. Sanchez's place, the extra cost for Ms. Sanchez would be 75 into 2, and that's 150, right? So if you are able to interpret a linear equation, and if you're able to understand what the constants stand for, these questions become simple. Okay, let's look at one more. The front of a roller coaster car is at the bottom of a hill and is 15 feet above the ground. Okay, so there is a, let's say this is a hill and this is the front of the roller coaster car. And let's say this is the ground and this is 15 feet above the ground. If the front of the roller coaster car rises at a constant rate of 8 feet per second, so it rises at a constant rate of 8 feet per second, which of the following equations gives the height in feet of the roller coaster car s seconds after it starts up the hill? So again, I can use the concept of y is equal to mx plus c, where y is the height and x is the time in seconds, right? So I know that the height, initial height is already 15. So my y-intercept is 15. And for every second, my height rises by 8 feet, right? So my final height after s seconds would be 8s plus 15, because the slope is m multiplied by the x value, which in this case is time, plus 15, which is the y-intercept. And so my answer is A. As simple as that. Okay. So that is how you interpret a linear equation. What about a linear graph? If you're given a linear graph, how do you interpret that? So let's say I have a question here. The line graphed in the XY plane below models the total cost in dollars for a cab ride in a certain city during non-peak hours based on the number of miles traveled. So the x-axis is the number of miles and the y-axis is the total cost for the ride. how do you interpret M and C here? So the first thing is I first look at C. I know that C is 3. So C is 3. And for M, I take 0, 3 and 1, 5. So my M will be 5 minus 3 divided by 1 minus 0, which is 2. So my cost is 2x plus 3, right? That is my cost, where x is the number of miles traveled and C is the cost. So what can I say about these numbers? So 3 is the amount in dollars that you have to pay just for hailing the cab, right? You haven't started riding yet. There are 0 miles traveled, but just for hailing the cab, the fee is $3. And 2 is the amount you pay per mile, right? So if you go 10 miles, you pay 20. If you go 20 miles, you pay 40. So the amount charged per mile, per X value, per unit X value, per mile is $2. That is how you can interpret this. Okay, let's do some sample questions here. Dominique spent $30 at a farmer's market. The graph shows Y is equal to Fx, where X is the amount of money in dollars Dominique could have spent on flowers, and Fx is the amount of money Dominique could have spent on vegetables. So X is the money that she spent on flowers, and Y is the money that she could have spent on vegetables, right? Which of the following is the best interpretation of the point 30, 0? 30, 0. What is the meaning of 30, 0, right? We know that when she has spent $30 on flowers, then she does not get to spend any dollars on vegetables, right? Because the total amount that she had was $30. So if the entire money, 30, has been spent on flowers, then no money is left on vegetables. So the best interpretation of 30, 0, which happens to be the x-intercept of this graph, is that Dominique spent $0 on vegetables and $30 on flowers. Option B, right? What is the best interpretation of the y-intercept? For the y-intercept, she spent nothing on the x value, which means she spent nothing on flowers, and she spent all $30 on vegetables, right? What is the best interpretation of this point, 15, 15? This means that of the $30, 15 was spent on flowers and another 15 was spent on veggies. So you see, it's very straightforward if you understand what the X value and the Y value are representing. Okay, let's do another one. A farmer collected pods from 2 species of bean plants, species A and species B. Within each species, the number of seeds in each pod is the same. However, the pods from species A contain a different number of seeds from the pods of species B. So there are 2 species, right, of bean plants, pod A and pod B, and they have different numbers of seeds per pod, right? We don't know what those numbers are, but they are different. The farmer collected a total of 90 seeds. The possible number of pods needed from each species to obtain 90 seeds are shown in the graph, where X is the number of species A pods and Y is the number of species B pods. Which of the following is the best interpretation using the y-intercept? The y-intercept is 0, 45. So he collected, if he had collected 0 species A pods and 45 species B pods, he would have obtained 90 seeds, right? Because each point on this line represents a collection of 90 seeds. So if the number of species B pods, if the number of seeds per pod is X, then 45 into X should be 90 because 0 species A pods. So A has not contributed anything. So X is 2, right? What does that mean? That the number of seeds per pod in species B is 2, which is option B here. Okay, let's try and interpret the x-intercept. What is the x-intercept? X-intercept is 30, 0, which means 30 species of pod A and 0 species of pod B. And here also, he was able to get 90 seeds. So let's say the number of seeds per species of pod A is X. Then 30X has to be 90 because B has contributed 0 in this case, right? So X would be 3. X is going to be 3. What does that mean? That species A has 3 seeds per pod and species B has 2 seeds per pod. And let's verify this. Let's verify this with this number. This number is 10, 30. 10 species of A will contribute 30 pods. 30 species of B will contribute 60 seeds, and the total is 90 seeds. So any point on this line is contributing 90 seeds based on our numbers. So that is how you interpret linear equations and linear graphs. Hope this video was useful. If it was, hit the like button and subscribe to the channel. Let me know in the comment section what other videos you'd like me to upload in this series. This is part of Basics Explained, a playlist where we discuss fundamental concepts of math. I'll see you all in a new video soon. Take care. Bye.